Ready. Ready. Ready.
Oh, I can't hear you, Whitney.
Oh, I did it! we were just talking pre-show about how it's been years where we do most of our communication over video, and we
Happens every time, right?
I was dancing too much in the pre-show, and I just
the music is awesome, straight up. I love that.
I'm not kidding either. I really am cutting a rug back here during the show. Anyway, let's just start the show with a genuine moment. I'm joined today with Daniel Bryant. What a gift to have you here. Daniel is head of DevRel and Ambassador Labs. Tell us about yourself, friend.
Thank you for the intro, Whitney. Yes,
Yeah.
so head of DevRel and an amazing team of folks at Ambassador Labs. We work in the Cloud Native Computing Foundation space. So super excited today to chat about Telepresence, one of the projects we donated to the CNCF a while back. And thanks so much for the invite, Whitney. Really appreciate it.
Oh, it's I can't believe when I started the show, one thing I didn't anticipate was how much I would get to connect with like freaking amazing folks from all over the CNCF landscape.
It's kind of cool, right?
I mean, besides getting like one-on-one masterclass lessons with experts, just like the really wonderful personalities and friendly folks. And of course, you're no exception. It'd be awkward if I did bring that up and be like, except this guy.
So my keys are like off screen, right?
There was no exception, but we're meeting him today.
That'd be embarrassing, wouldn't it?
One thing, the Telepresence logo is so distinct. Like there's a little friendly Telepresence. Where did that come from? Or can you show us? You showed me a figurine.
I'll reach back, everyone, into the. I've got little Edgy. We call him Edgy. So I don't know actually. The light. There you go. This is like a stress ball. We actually gave these away at Detroit in KubeCon NA. And so there is a story. So initially, there was a collection of tools at Ambassador Labs. It was actually called DataWire. So the company started as DataWire back in 2014, I think.
Okay.
And there was a series of tools called Blackbird. And it was based on the SR-71 airplane. If folks are into airplanes, I'm an airplane geek. And then there's this famous like spy plane that looks like a Blackbird that goes super high orbit and takes like spy pictures. It's an amazing like plane.
Wow.
And then the Blackbird, there was 3 projects at the time. There was Telepresence, Forge, and Ambassador API Gateway that became Emissary Ingress now, another CNCF project. But the 3 of them all had Blackbird logos. So you may think this is a penguin. Everyone thinks it's a penguin.
I would have thought it was a penguin.
It's actually a blackbird in a tux. Every time people are like, penguin? No.
and so the Telepresence little buddy is related to the black.
Yeah, and if you look, he's actually got SR-71 on like the shorts, and that SR-71 is like the logo or the code name of the Blackbird spy plane.
Amazing! I would have never guessed spy plane.
Yeah, it's honest. So I've been with the company almost since the start. So this is proper history, right? Most folks are just like the penguin. Like, what's the deal? He's got VR goggles on. I'm like, it's not a penguin. Like, called edgy, and then there is a whole story. Like, it's great to dig into it. No one asked me, honestly. No one asked me about the history actually, but there is legit history with all the logos.
I think I don't know if I thought penguin, but I definitely thought VR goggles.
Everyone said, well, the famous thing is angry penguin. We actually like get folks coming out to booth. Angry penguin, because it looks quite serious, right? Like a little edgy. And no, it's a blackbird. So.
We have some friends to say hi to. Lisa's here. Lisa's a great supporter of the show. Thanks for being here so much, Lisa. And then Fuel Snovel's here too. Hi, Fuel Snovel.
Hello.
Yay! Amazing. So you are head of DevRel.
Yes.
I know I only just learned DevRel existed just in time for me to get a DevRel job.
Nice.
I even have this like DevRel red streak in my head. I've had this for like 15 years. Like I feel like I was DevRel before I knew what DevRel was.
I like it. Yes.
But travel's a big part of that job. Have you done a lot of travel as head of DevRel, or is that only for us people on the ground?
I've done both roles, Whitney. So, so I've definitely sort of like grown
sense.
Into my head of, right? Like I've done like sort of all three of the tracks, and throughout my career, there's always been like a kind of like teaching kind of element. I love teaching.
Nice.
So yeah, I've traveled a whole bunch. I mean, super like we're privileged, right, to be able to fly around the world, meet amazing people, like and chat to them. Pre-COVID, doing a whole lot. I just started back actually, I think March last year, and we went to Vegas because Ambassador Labs are notionally. Like we're actually a global company, but like HQ, the beginning was based in Boston in Massachusetts. So a whole bunch of folks on the West Coast now as well in the States, and all over Europe and Africa. We're everywhere out now these
Amazing.
days. But we all traveled into Vegas. So like that was my first post-pandemic trip last year, March, and it was good to be back traveling. And now I've been traveling not too much, but quite a bit, like in the States in particular. Recently, Boston, New York, DC, always good fun.
Do you have a favorite place? Like.
So I think favorite place in America, because I'm too lucky traveling everywhere, so it was probably New York, right? And my generation, I grew up watching Friends, the TV show, right? And like the original run of it. I'm sorry, I don't show my age here, but the original run of Friends, and like all the movies I was really into as a kid were like a lot of them are based in New York, right? The classic Statue of Liberty. So that was one place that just didn't disappoint. I rocked up like many years ago now traveling, and I was like, wow, like New York is New York. You got to own it. It's got issues as every city has, right? But I just love the vibe. I love the energy of New York. Yeah,
I felt similarly when I visited London last year for DevOps UK. I watch enough British television or British movies that I totally felt like I was on set.
It's the same. It's like we've got like British Bake Off. We've got all the period dramas, right? Like we don't all speak. Like, my accent's relatively neutral, but like there's a lot of variations of accents in the UK, right? And depending on what TV show you watch, you expect different accents, but we all speak like very differently, right?
My son and I got very into British Bake Off during the pandemic. We watched every season
all the time. Like people were constantly on my team are mocking my accent, saying, "When am I baking?" And I'm like, "Look, banana bread. That's about my limit, right?"
It never occurred to me to extrapolate that show to anyone I meet with a British accent. I apologize to the rest of the world for doing that to you.
It totally happens.
Wow, that's news to me too. Okay, so I'm gonna start moving back over to the UK office is a good show. Says Fuel
I love the UK office. That's a good show. Yeah,
I watched the UK office before the American office even existed. It's extra cringy. Yeah,
straight up. I worked. So my very first job was in the UK government, and be careful what I say, but like there was a lot of similarity with that office and the office on TV, right? So good show. Yeah.
It was too relatable. Yeah. And then Lisa says AbFab is. I don't know what that is.
Oh, absolutely! Wow, Lisa, that is great knowledge. Absolutely fabulous. Have a look, Whitney, on like BritBox or one of the TV channels. Like that's cringeworthy but very funny. So good shout, Lisa.
One of my favorites is IT Crowd.
Oh, I love that one. Same deal, right?
And then Fuel Novel says, cringy, what are you talking about? Related to the British office. Okay, Okay, so I'm going to start moving back behind the board. I have a question for chat. So telepresence, what I understand of it so far is that it helps ease the pain of developing an application that's meant to run on Kubernetes.
Yes.
So for those of you, if there are those of you watching right now live who experience developing on Kubernetes, what tools are you currently using? What pain points do you currently have? Tell us about your experience. And then for you, Daniel, I would love to hear about your career path getting into head of DevRel. Yeah. Tell me
Whitney.
about yourself.
It's a good question. So a lot of folks look at the DevRel like discipline and wonder, how do you get there? Like, what's the career track, right? And it's really interesting because nearly everyone I speak to in DevRel, and you're no exception, Whitney, has had a different and interesting career. Do you know what I mean? Like it's often very different. So I actually started as an academic, believe it or not, back in the day. I was studying defeasible logics for any of the fans of the non-monotonic logics out there. That was my thing. But it was way too theoretical. So I decided to, at the time I was doing some consulting, I think, web development, and I just enjoyed that much more. It's like much more practical. I was building stuff, seeing people use it, rather than dealing with these like obtuse and theoretical kind of like calculations and things like that in the academic world.
What I'm hearing is you like people, that
I think so.
That you're working more directly with people.
I'm an introvert at heart. I don't know if like a lot of folks in DevRel, it's quite funny. Identify as introvert, right? It's kind of strange. People are like, you're on stage. And I'm like, no, I just play an extrovert on stage. I am totally an introvert, right? But I always love I always love the teaching aspect of it, the connection with people. There's nothing more magical. When I was at university training to be an academic, you had to teach, right? There was nothing more magical than seeing people in my class suddenly get some concept they didn't get before. And I was like, oh, I want to do that, like whatever I do, right? So, and I totally took that as in, even when I was my very first gigs doing Java development and like architecture, I'd take any opportunity I could. Like the meetup scene was becoming a big thing in London around 2010. 2012. So I met some amazing mentors on the London tech scene, and that's when I got like open, like my eyes were open to like the opportunities out there. You can do operations, you can do architecture, you can do marketing, you can do whatever you like. And then my journey is like gone along the way in terms I did dev, I did ops, I did architecture, I did consulting, did a couple of CTO type gigs, and then I was doing a lot of consulting in like 2017, I think, where it was. And then I fancied doing product stuff. And that's when I very fortunately bumped into Richard Lee and Rafi Schloming, who are the co-founders of Ambassador Labs, DataWire, and got chatting to them. I think I actually hung out in Austin, Texas, like 2017, KubeCon. And like that was like November time, I think it was. And we got chatting, and then like they offered me a job like in January of like the year after. So it's like a fascinating journey, and like something I'm sure like you see a lot, Whitney, as well. It's like community is at the heart of these things, right?
Connecting 100%. I have a question. Something I've experienced is some people have some engineers are interested in the DevRel space, but really dislike the title of developer advocate. Like they feel I don't like they feel like they're above it or something.
I hear.
What's your take on that?
Yeah, I do get it, because when I was like a full-time engineer, even I sneered at marketing and sales. If I'm being honest, right? I was a bit naive back then, and now I realize that like there's everyone in the company is vitally important, and you can have amazing people like at all like different things. Like being a really good salesperson is like it's really hard actually, right? Being a really good marketer is really hard. So I think there is this like temptation. I think the sales folks, marketing folks probably do it to us, right? As engineers, like, well, look at those engineers with their funny codes on the screen or whatever. And I think it's kind of tribal to some degree, right? We identify group with ourselves, but I mean there is a bunch of different titles out there. I see some folks that are doing DevRel like stuff but don't want the label, and again I understand that, but they're calling themselves things like developer experience engineers, right? And there's even like I've even heard, was it like we used to have dev in test was a big thing back in like when I was consulting, and I think they call themselves something like dev in marketing or DevRel engineering or something like that. So like a case of like I'm still an engineer, but I just happen
still get
to
that word in there.
That's it. I happen to do some kind of. For me, DevRel started teaching primarily, right?
I think my title is a technical advocate instead of developer
Ooh.
advocate. And I didn't make that up, but
Mm.
just to encompass that I'm not just helping application developers. I'm not
Oh,
just meant
that's
to.
really good. That is a really good shout because we see more and more folks talking about platforms, Whitney. I'm sure with you like Tanzu, right? And like talking
Uh-huh.
more about platforms, and we're very much doing platform work as well. But we do primarily work with developers, but we also work with operations and platform folks. So developer
Yeah.
advocate is not, it's more like engineer advocate or technical advocate.
Uh,
I take your point.
uh-huh. Yeah, yeah. I didn't get it at the time. I was too naive, but I get it now and I like it.
Yeah,
um
it's a really good
uh
point.
Fuel Snowball has a lot of great things to say. I thought Kubernetes ran on pain.
Every scream fuels the engine, right?
Your tears.
So yes.
Fuel Stable has been advocating for me to start using permanent markers and having disposable light boards, or just like a
You
room of
frame
light
them, like
boards.
put them in museums, like Whitney, right? That's the thing.
Oh, there we go. It is a little bit sad to erase last week's. Like I get a little bit attached to it when it's time to. Um, Fuel Stable says miscellaneous dev, do anything that pays my mortgage. Yeah, I mean,
Very
but
fun.
it's more fun that way. And I think as you have a range of experiences, then you become actually more qualified in every one because you're teaching your brain to think different ways. Like
Yes.
I think there's a danger actually in staying in exactly one thing for a really long time because your grooves get too deep and then you can't dance around a problem the way someone who jumps around maybe could.
Yeah, something we mentioned off mic, and you framed it perfectly. When it was growth mindset, right? Like how to X
Mm,
growth mindset. Love that stuff, right? We optimize for that in Ambassador Labs, and personally, I love that. And if the grooves get too deep, it is hard to like get that growth mindset going, right? Learning constantly.
yeah, yeah. I think I'm addicted to learning.
Ditto. I love it, right? Whatever history, art, love it. Yep.
It's a good problem.
Yes.
We're all set up and ready. Speaking of addicted to learning,
Fantastic.
I need my fix, Daniel.
Go.
As regular viewers know, I love to start this part of the stream by asking, what was the world like before your technology existed? Like, what problem existed that caused telepresence to need to get made?
Yeah, great question, Whitney. And if we cast our mind back to, I think it was like 2017, and this small little project called Kubernetes was in, I think, version 1.2, 1.3. So like that is definitely a prerequisite for kind of the things that are happening, right? Kubernetes was a thing, it was seeing
Okay.
traction. People were like, oh, I think I want to deploy my apps onto this Kubernetes thing, right?
Yeah.
But they were having a real hard time when they got to a certain scale of applications. So
Uh-huh.
typically people were doing microservices. That was very popular back then, 2017,
Yes, yes.
right?
Uh-huh.
And
Is it
when
not
they,
popular now?
well, it's becoming popular. So I'd say like
Oh,
microservices
okay.
kind of bought 2012 and it became
Okay.
mainstream around 2017. And now it's
Okay.
almost a bit like laggard, maybe, right? I don't
Okay.
know. Microservices were a big thing, and people weren't really sure exactly development best practices. And when you
Uh-huh.
coupled all these microservices you're working on to build your application, and this
Mm-hmm.
new thing called Kubernetes, and you were
Kubernetes.
packaging typically Docker apps, right, or containers, you're packaging all your apps in containers. Folks were finding it really hard to get fast feedback on applications they were working on.
Mm-hmm.
So one of the key pain points when you got to a certain size of application, you couldn't run it all locally on your machine unless you had some like very big machine. And obviously back 2017, like the machines weren't quite as powerful as like what we've got now, right? I think my Mackie has got like 64 gigs of RAM, but back then I
Mm-hmm.
think that was pretty hard, to get hold of. So that was very much the before era. And I remember, I think it was Kubernetes 1.3 where Minikube was launched. Now we take Minikube like for granted, but
Yeah.
yeah,
And there's like a
that's it.
K3s, like there's so many of them. Yeah.
Yeah, this was like, so people were like, how do I run Kubernetes locally? And the answer was like, you can like, Kelsey Hightower's like Kubernetes the hard way type thing was the only real way to spin it up locally. But Minikube, but
Wow.
the problem's recognized and folks are like, we'll create this Minikube thing. And it was amazing. Apologies, I don't remember who created Minikube, so I'll sort of give the shout out to that, the names, but Minikube was game changing for being able to spin up a Kubernetes cluster locally and deploy and test there. But you still, after a certain size of application, you couldn't put all your services into your local Minikube. Do you know what I mean? You were like, oh, I'll deploy them remotely, but now I've got to like build my app, package it in a container, push it up to a remote Kubernetes cluster, run some tests, check some stuff works. Oh, it doesn't work. Then the cycle begins, right? Then I go back and I go, right, make some more changes, locally, package it up into a container, push it to a remote registry, deploy it to Kubernetes, test again. And that was, I was actually Java developing using Java at the time. And that was just painful. I wanted fast feedback. I wanted to stay in my flow, my zone. And I was constantly like certain things I just couldn't get right. Like I wanted to test them against like other services in the cluster. And I had to go through that super slow build, push, deploy loop every time with the container.
Yeah. The flow state is a big deal, and to get out of flow state and then back into it every time you're trying to deploy a new version of your application, that does sound terrible. And when we had asked what are our microservices still a thing, Fuelstomble said nanoservices.
I love it. Yeah, that's true. Like with like Lambda and just in general, like pretty function as a service, like Knative. I know like Knative, like very widely used. Like I think like these days it's like monolith, microservices, function, nanoservices. They're all valid options, right? But definitely in 2017 it was like microservices or bust. Everyone was just going microservice, all in, right?
Yeah. Well, I mean, I say that what I was doing in 2017, who even knows? But 2017 was just 5 years ago.
I know, that's right. Yeah, 5 or 6 years ago, right?
We're talking about like it's ancient. Time's weird. That's,
in Kubernetes world, I joke it's like cat or dog years, and they say like cat or dog years, like 7 of our human years, right? I think it's like that. We just move so fast.
I just realized I didn't put our telepresence links into chat, so I'm going to do that right now. Let's see how well that worked out. Are those clickable? Oh, that's not beautiful. Sorry, but it's there. It is what it is. So before telepresence, let me make sure I captured everything. We're having a hard time getting fast feedback. We're having a hard time running Kubernetes locally to try to work with Kubernetes.
Yes.
I don't know if we want to write down the whole flow state thing, but I really identify with like getting out of flow state is hard. It's hard to get back into flow state, in and out. Is there something else you want me to capture here?
I think that's it. So that was the kind of the itch that was wanting to be scratched within the DataWire team. They were, because like DataWire at the time were actually working on some of these, building these systems, and they were like, oh, there's got to be a better way like to do this. And I think that's pretty much it. It's the fast feedback, and it's like the cost and the time. It was really hard to run Kubernetes locally. Like now it's just like expensive to run it locally, right? But that's great, Winnie. It's good stuff.
Okay, great. And then Fuelstomble says, don't microservices tend to start small and evolve into big services?
It's a good question, Number. Yeah, because I definitely saw that where people were like best intentions with like, hey, this service, and then like rather than understand like how to build perhaps another service or the context of that service, people would just augment the service until it became a mini-lith or a monolith itself, right? I've seen that.
A mini-lith.
Yeah, that was like best intentions sometimes, the mini-lith.
Abhishek's here. Hi, Abhishek. Hey, thanks for coming. Okay, so I guess telepresence is going to help solve this problem. So what is telepresence?
So it's interesting when you say, I'll frame by saying there is two versions of telepresence. And do you want me to tell you like the history? Because there was one that existed up until, I think it was like, I made some notes actually, it was like 2020. And then we fundamentally changed the architecture. But it's the same solution built slightly differently with different trade-offs. And it's like, from my perspective, it's kind of interesting to know the journey that telepresence.
I love it. I love a journey. Yeah, I'm going to put my marker down. Tell me a story.
So with the first version, I made the notes. Itamar Turning Trauring and Abene Saxena were the folks that were initially working on it, and they were bumping into the two problems you've got up on the lightboard there. They were like, hey, I can't get this fast feedback, and it's hard to run Kubernetes locally. So they came up with an idea of, can we swap something out in the Kubernetes cluster with a proxy that joins, a network proxy that joins my local machine to that remote cluster. And the TLDR, kind of, Winnie, in terms of the two, like, eventual two solutions that came out there, the very first version of telepresence, written in Python back in 2017 or so, literally swapped out the deployment. So in Kubernetes land, like we have our services and our deployment, it sort of swapped out the whole pod effectively with a proxy. And
Okay.
that meant me as a local developer, or me as a developer on my local machine, I could type stuff in on my terminal and access the remote cluster as if I was in the cluster, because I was proxied into the
Okay.
cluster. And the
Cool.
cool thing was I could also get traffic destined to that remote service routed to my local machine. So this is where you get the beauty of the fast feedback going on, right? You have all your apps running in this remote cluster. So like someone set that up for you, right? Remote cluster, and you're working on one of the services, right? We can now just have that one running locally, like normal, and we can test the main application running in this remote cluster, but route traffic to my local machine when that service is called. So I can get super fast feedback because I can use all my normal local tools on that one service I'm running locally. And it's like that service is in the remote cluster by the magic of the network proxying.
That's super cool. So in this cluster you're describing
Yes.
is not like a production cluster. It's a cluster that's meant just to host everybody's
It's a good point. It's
test
very,
version.
yeah, that's a really good point, Winnie. And you were very brave if you did it in production, because like you could,
Yeah.
but it would literally swap out the deployment and all your user traffic will be routed to your local machine, right? So
Okay.
we do have folks that run it in production, like legit, but they're typically like pre-product market fit, like no customers, right? So like, as in, if
Okay.
you've got customers, you do not run it in production. Yes.
Because it's 100% of it's going to your machine. It's not like split and going to both places.
Well, this is interesting. So the second version of Telepresence that was released in 2020, you've queued me up
Okay.
perfectly, did provide that. So it uses a different mechanism. Rather than swapping out
Okay.
the whole deployment, we now use a sidecar model and put the proxy next to services. So that means that we can actually make a choice.
I
Go
have
for
a
it.
question. I have a hard time with the word services because in Kubernetes there's a service and
Yeah,
then
right.
there's a microservice that means application. When you say service, will you help me understand?
Yeah,
Do you
good
mean
show,
like
Amy.
application?
And I use them interchangeably incorrectly, if that makes sense, because like there is the Kubernetes capital S service, right? Like that, I'm with you on
Yeah.
that one. Like we define a service, and when I'm saying services, I mean typically microservices.
Okay.
But call me out on that because yeah, it's a good point. I just swap between the two of them. My default is often talking about architecture. So when I'm saying like running my services locally, I'm running my microservice or
Okay.
microservices locally.
Okay. A lot of being a new learner is just understanding the vocabulary. And so I think
Totally.
I might ask for clarification on that point a lot of
Go
times,
for
or
it.
maybe
Go
we
for it.
try to say Kubernetes service and microservice when we use the two words.
I like it. I
Yeah.
like it. I'll try my best. Yep. No, that's good.
Okay. It's just my child's mind. Thank
That's
you.
good stuff. That's good stuff.
So back to what you're saying, running the service by microservice in the cluster now as a sidecar to
Yeah. So
the
this is like
application pod.
Telepresence V2, like because
Okay.
before we sort of straight swapped out the microservice, like and to be fair, it was the Kubernetes service as well, but we straight swapped out that service for a proxy that would just route all traffic to your local machine and vice versa. With V2, we added another container next to your microservice. So running in the remote cluster is your microservice in a container within a pod, and now we put another container in that pod that is a proxy that routes traffic to and from my local machine.
So in practice, like, does a company have like a whole development cluster that's just filled with everybody's telepresence
Yeah, that's what we see now.
applications?
Yeah,
And so
yeah,
it's okay.
yeah, we see like so one sort of model that was almost an anti-pattern is when every developer has their own cluster. Like you quite often see that, right? If you can't run everything
Yeah.
locally, you basically spin up your own Kubernetes cluster like in your cloud of choice. But that gets very expensive quickly, right? Because you're paying for all the VMs, like every developer has effectively a VM in the cloud, and you have to maintain those environments, right? You have to make sure they're up to date with Kubernetes versions, up to date with all the microservice versions, all that kind of stuff.
Yeah.
So with Telepresence V2, which
That's
is the default these days, because you can selectively sort of route that traffic, we often see not maybe one staging cluster, but like a handful. Do you know what I mean? So like you
Okay.
pick a number, maybe like 5 to 10 developers in one cluster, because if you get too many people working in one shared cluster, you often
Mhm.
find things like mutating shared state gets in the way. So you're messing
Yeah.
like that you can swap as many services out, microservices out
Yeah.
as you like with Telepresence, but like if you're messing around with databases and queues, you're going to bump into your fellow developer.
Yeah. And if you're relying on understanding this other service that's next to your service and they're also developing
That's
it
a good
at the
point.
same time, yeah,
Yes,
then
really good point.
then you're not getting a real picture with if you deployed it right now, what it would look
Totally,
like
totally.
in
Yep, good point.
running. So I kind of understand what you're saying, but I want to draw it.
Love it,
Uh,
love it.
so what I'm hearing is there's a pod that's running. Well, actually, why don't you tell me instead of me guessing
Yeah,
from an
so I'll
architectural
think
standpoint?
back to my Kubernetes architecture. This is great, Winnie. So, so let's focus. Let's keep it simple. Like, I hope I haven't complicated focus. Let's focus only on like Telepresence V2, which is the default
I
Telepresence. If you go to the repo, download it, you'll get like Telepresence V2. But just let's say Telepresence, right? So
Okay.
first off, Winnie, how should we do this? Let's put a pod in the
Mhm.
cluster. And
Mhm.
within that pod, let's have a microservice running in a container, but leave a little bit of space next to that container for like the sidecar later. Does that make sense?
Okay. Yes. Is this hitting the pod first thing, or should I put the pod over here? Is it going to hit something else
Uh,
before the pod?
it's going to hit something else, but we could
Okay.
Google it. Yeah, it's going to hit a traffic manager.
Okay. So we have a pod,
Yep.
and then this pod has a running application.
Yeah.
Okay, with room next to it. So that's app.
I don't know if you will like want to draw this because it's going to get pretty busy, Whitney. But like, if
Am I
folks
doing
can
it too
imagine,
big?
no, this is great.
Oh,
But I
okay.
can
Okay.
imagine just to like sort of because I like when we teach, it's nice to keep things like simple. But imagine like you're working on a service with like 50 of these pods or what like with different services. Do you know what I mean? You're building an application where
Yeah.
there's a lot of dependencies. So like even though we'll keep it simple because otherwise the diagram's going to get really confusing. Just
Mhm.
imagine that you're working on
Can,
this application with 50 services.
when it has 50 services, are you and Kubernetes services, or you mean microservices?
In this case, it is one for one
It's
typically.
kind of
So like
one.
you have like
Okay.
you define
Cool.
like a Kubernetes service capital S, and they
Got
typically
it.
like that's one to one for a microservice.
Gotcha.
Yeah.
And you're talking about maybe like Postgres, or like what are some examples of these 50 different things that might be running when you're
Postgres is a great example. Like when
okay.
you always see some Postgres on MySQL, right? Like
Uh-huh.
that, or you may see like that outside of the cluster, like in a cloud service. That happens too. The sort of the common services we see are the services, the microservices that make up your app. So
Okay.
say we're building an e-commerce site, like you might have a product service, you might have a checkout or a cart. Well, you'd have a cart service,
Okay.
right? So you put the product in the
Excellent.
cart, checkout service, payment service, that kind of stuff.
And then are those just like probably identical of what's running in production, or are those also currently being developed, which is kind of something we touched on?
Yeah, and that's where it gets tricky. When you like in an
Okay.
ideal world, you like your staging environment, you want to mirror as closely to production as possible. But with
Uh-huh.
microservices or nanoservices, we had, there's always going to be some lag. Do you know what I mean? Like because
Yeah.
like particularly if you've got big teams, and
Mm-hmm.
you phrased it perfectly when just a minute ago. Like if there's going to be multiple work streams, right? So you and I are
Mm-hmm.
pairing on like the cart service, and then these
Mm-hmm.
folks here are pairing on the checkout service. Like because we're both working on things that are dependent on those two services, we actually
Mm-hmm.
might want to work in completely separate clusters because to your
Okay.
point, otherwise we would trip over each other.
Okay.
Yeah, it's a good
So
call out.
it's okay. So it's something that's optimized for on a case by case basis and
Yeah, it
considered.
is, and it's sort of like there is like sort of best practices emerging, I think, but and capturing those actually would be really nice. But it's still quite, there's a lot of sort of bespoke approaches to how folks work and like collaborate, and it's almost like a higher level than Kubernetes, because just like when you're working on a shared code base, that's just really hard too, right? Because like
Mm-hmm. Yeah.
who owns that, and what, do you know what I mean? Coordination. Same deal with
Yeah.
microservices. It didn't make it
Uh-huh.
any easier necessarily.
Well, Feel Snowball has something to say. Feel Someone says, I sometimes think that the main benefit of microservice is the ability to scale up the org to lots of devs that can work reasonably independently.
Totally agree with you, Phil Schnabel. Yeah, totally agree with you on that one. And I think that's the dream, right? We talk like from our architecture days of high cohesion and loose coupling. And if you get that right, like properties, magic happens. But all too often, I think as Phil Schnabel like pointed at, services grow and they lose that cohesion. Like suddenly you've got different pieces of functionality bolted together, or they're like a classic play, and you know something we've touched on, Whitney, is you get two services that are so tightly linked they have to be worked on and deployed together. And that's not two services really, that's one service mashed up, right?
Might as well
So
run in
like
the same pod at that point. Yeah.
pretty much, right? So like I've
Yeah.
definitely seen that in my career as well. So you have to be careful, like just going back to my architect days, always think about designing for high cohesion and loose coupling. And if folks are interested, things like domain driven design, still fantastic. I'm sure folks have bumped into that. But there's a bunch of patterns that help us as engineers model the world we're building effectively.
Excellent. All right, so we have our application running in a pod in a remote Kubernetes cluster, and we want to proxy our development environment through to that application.
Yeah, so in the new world, you
Or
download,
the
you go and you download Telepresence on your local machine. So it's like it's a binary application, Telepresence. You download that, you do Telepresence Connect, and it would then spin up a local daemon on your development machine.
Okay.
And it would also install in your Kubernetes cluster that you're connected to via kubeconfigs and kubectl. It would install a traffic manager
On your machine.
No, that's in the cluster, Wendy, the traffic manager.
Okay.
So that's the Telepresence daemon in your local machine, and that's sort of like manages all the like it keeps the state of the connection open.
Okay.
And then if in the cluster there'd be a traffic agent, sorry, a traffic manager. Sorry, let me get my terminology right.
I want to write TP on there, but that stands for toilet paper.
Someone else said that to me the other day. I think that's an American thing, because in the UK we do not have that. And I'm like, TP
oh,
what?
Yeah.
Like, I said, yeah, like
even as a verb, like you could toilet paper TP someone's house, meaning like like
that's exactly what they said as well. They were like,
trees.
when we were growing up, we were like TPing someone's house. And I was like, in the UK, we do not have that.
This is a traffic manager.
Yeah.
Yeah.
I like this. This is good. It's so
TLP.
hard.
Yeah.
You're doing a great job, because it's so hard to know where to put things as we grow this diagram, right? But I think you've done really good so far. Thank you.
my strategy is to keep everything to the right, so there's room to sit in between. I guess I made an assumption that only the traffic manager needs to sit in between, but we have this room down here.
And that's looking good. We can put perhaps like an ingress or something like that at the bottom, but that is looking great so far. And the magic happens when you type Telepresence Connect. The daemon on your local machine connects or forms a tunnel effectively to the traffic manager.
Okay. Nice.
If folks are used to things like SSH, like it's very much like that. It actually uses some different stuff under the hood. The original Telepresence used something called SSH shuttle or S shuttle, which was a SSH VPN bit of technology, but we've changed it with the new version of Telepresence. That's great. But you imagine now when we type Telepresence Connect and it connects into our cluster. Now, if we're on that machine, Whitney, and we're typing, say we've got a service that we know is available like in the cluster, or like cart service .default, so default namespace, right? Cart service .default. We know the port running and we know an endpoint. We can now on our local machine hit that endpoint. So we can type curl cart or curl app .default magically like we were in the cluster. Because before we had that connection, if I was to type curl app .namespace, like quite rightly, my terminal would go, I don't know this domain name. Like, what's this? Like you would say, like, nothing found, right?
Makes laptop available locally.
So
as though it was local to the cluster.
Yeah, or the way I phrase it, it makes, you can actually phrase it multiple ways, but like you either say it puts the laptop in the cluster. That's one way of saying it, right? Puts the laptop in the cluster, or it makes the remote local. And the reason why I quite
Oh,
like
here's your Remocal
that's it. You
word.
got you keep me up,
Oh.
yes. Because I love this Remocal word, but it's not a word, folks. Like on this one, I think like I can't remember, I don't know if we made it up or we kicked it around. I will hat tip the Influx DB folks because I saw them using it in one of the talks about telepresence, and I was like, "You're awesome! I love that word." So I'm not sure who actually invented it, but yeah, that makes the remote local.
I'm gonna. What was the first one you said? It was a little more child's mind, which I
Yeah, I like
liked.
it. It was it
Puts
puts
your
your
laptop
laptop
on.
in the cluster. Yeah.
Okay.
And like that's kind of like exactly what is happening, right? Well, not exactly in terms of like literally, but like that is a good mental model.
Cool.
Perfect. So that's the first stage of telepresence, and that provides a lot of value for folks, right? Being able to literally you can now like spin up like a Postgres client in a local machine and connect into a remote database running, right? Because it's like a TCP tunnel. So like anything you can hit in the cluster, you can now access
So,
locally.
so if you had a Postgres running here, you could just connect it to your app.
So other remedy. So if you had a Postgres in the remote cluster, you could
Okay.
use a client on your local machine and access
Okay.
it like it was on your local machine, but it's actually
Okay.
running in the remote cluster.
Cool. So our relationship to this application that's running is that we can develop it from our
So
local
at the
laptop.
moment, so the first stage, the Telepresence Connect, I often use it
Uh-huh.
when I'm exploring like my world in the cluster. So at the moment, what we could do is
Uh-huh.
we could curl that app like and interact
Uh-huh.
with the API as if we'd
Okay.
spun up everything locally. Does that make sense? It's
Okay.
running remotely, but we
Mm-hmm.
can interact as like at the moment we can just like I often do this when I'm trying to understand an API that's running remotely.
Mm-hmm.
I'll Telepresence Connect. I'll start curling it with JQ or whatever,
Mm-hmm.
and then start poking around with it. I don't need to
Mm-hmm.
spend time spinning up things locally. Telepresence Connect. My ops team, my dev team, that's already maintained this remote cluster. I just dive in and I start playing around with it. So the moment it kind of like this is just mainly sort of the experimental or the understanding phase, Whitney, if that makes sense.
So when the internet was new-ish, my my son and I used to really like a website called Stuff on My Cat, where people
Stuff. Oh
just
my
lit. Yeah. So if this was Stuff on My Cat and I wanted to see photos of people of cats with stuff sitting on the cat, I could see that from my local thing. I could be like, hey, I could hit this.
Yeah,
I could curl it
totally. Yeah.
to access that stuff, but I'm not actually developing the app.
Not yet. No,
I'm
we'll
just
do that like in a
consuming the
minute.
app.
And
Yeah.
that's a really good point, Winnie. So you can imagine, like, because so there's stuff on my cat, like in Kubernetes world, we'd need an ingress too, right? If you're going to
Uh-huh.
release your
All
application
right.
to the public, you need an ingress. So
Mm-hmm.
like there's Ambassador, like we've got emissary ingress, there's Contour
Mm-hmm.
in your world, right? And there's a bunch of other ones out there as well, Nginx, a bunch of other ones. But you need that ingress
Mm-hmm.
to get people, allow people, sorry, to actually access the applications, the services, right?
Mm-hmm.
That to your point, when say you were a developer on stuff on my cat, at the moment
Mm-hmm.
in that cluster we have not got an ingress, right? So no one can
Mm-hmm.
actually view the cats. That makes
Mm-hmm.
sense. Whereas now
Mm-hmm.
you've connected with Telepresence, you could view the cats by calling
Mm-hmm.
directly to that app. Does that make
Mm-hmm.
sense?
Yes. Yes, that's great. So now, so we can access everything running in the pod without having to deal with an ingress
That's it.
or
We access anything in the
certificates or any of
cluster,
that stuff.
anything in the
Uh-huh.
cluster, basically. Like we can curl any, because now our local machine kind of shares the same network namespace as that Kubernetes cluster.
Mm-hmm.
So we can curl via service name, we can, as in Kubernetes service name, we can curl via IP, it's like 10 dot da da da.
Mm-hmm.
Because we do, and what you made me think there when you with the cat example is we do have folks that like have not exposed their application publicly, but they want to poke around like with stuff in
Mm-hmm.
the cluster, right? So the Telepresence Connect, and they can sort of use it like it was exposed with an ingress, but without any danger of anyone finding it via the ingress or hacking it or whatever, because like we've got this like secure tunnel into the actual cluster, right?
Mm-hmm. Cool. I'm gonna
Should
draw
we
a
move on
cat
to
now.
developing? Yeah, nice. Yeah. Because the developing
Yes.
thing is the interesting bit, and it gets more complicated. But I'll try my best to walk you through it because it's a good exercise for me teaching this. So imagine we've got our 50 other microservices in there, right?
Okay.
And now
Stuff
you and
on
I
my dog, stuff on my
yeah,
lizard.
love it. So we
Stuff on
want
my
to
ostrich. Okay.
so we want to work on the stuff on my cat,
Uh-huh.
and that stuff on my cat is dependent on all these other services, right? So
Uh-huh.
like, I could spin it up locally, and just for like folks in the room, because everyone always asks this, is a really good point. Like I could just mock services locally, right? I can use
Yeah.
service virtualization locally, like Wiremock or Hoverfly, and you totally can. I'm like, I love that principle, but there's sometimes where you just need to interact with stuff that's like real, like actually like
Mm-hmm.
real in the cluster, right? So sort of that's the kind of scenario I'll give you. We need to access all these like stuff on my dog and all like, but we want to effectively pull stuff on my cat to our
Uh-huh.
local machine, so we can just spin up an IDE, start working on it, right? But we can
Uh-huh.
interact with all these other services. Does that make sense?
Yeah, that makes a
Yeah.
ton of sense.
And the beauty, like, and to go back to this ingress thing again, if you imagine we do, maybe we do want to put an ingress in there actually, Wendy, because you imagine if I was testing against the ingress to actually see like what would my user see,
Uh-huh.
right? And we want to dynamically change stuff. We can totally do that with telepresence, because telepresence is a two-way proxy. So up to this point, we've only really talked about us as engineers reaching into the cluster and like seeing data, right? But we can
Mm-hmm.
also route traffic from our remote cluster into our local machine.
Okay.
Yeah, that's nice. I like that. It's good.
Yeah, I'm gonna put a user over here.
Nice.
That's cool. Cool.
Love
So
it.
user
Yep,
can still use it through the ingress and still access. So for
that's right.
testing, it
And
would
when
probably be for
even
testing.
for us, like we can do that, right? So we can be running
Yeah.
stuff locally, but we can be calling like it might be like, you know, Whitney's test stuff on my cats.com or something,
Uh-huh.
right? And that's like
Uh-huh.
that's mapped to your ingress, and then you're seeing it like a user would see it. But if we just do like now what's called a telepresence intercept, and we'll keep it sort of simple because there's different types of intercept, but this global intercept I think is the best thing to
Mm-hmm.
start with. If we were to type telepresence intercept stuff on my cat app, right?
Mm-hmm.
What would then happen is a sidecar container with a proxy. And for folks who are interested, it's Envoy proxy. We all know and love Envoy proxy.
Oh,
It's Envoy proxy, like gets injected as a sidecar.
I want to do an episode of Envoy Proxy soon. If
Oh,
you happen to know
awesome.
anyone.
I can hook you
Yeah.
up. Like we all know all the Envoy folks. They're amazing people. And like
Okay,
there's
great.
Google, there's Lyft, there's like many folks contribute to Envoy, and like it's an amazing bit of technology. Amazing.
Cool. So this is an Envoy proxy.
Yeah.
We'll talk about it after. Envoy proxy. Okay.
Yep. And that now can so when say another service, and it could be in our example, let's keep it simple, our ingress wants to talk to the stuff on my cat app, like
Mm-hmm.
we're gonna configure the pod and all the definitions to instead talk to the proxy, sidecar proxy.
Mm-hmm. Okay.
And like we'll keep it simple at the moment, this global intercept concept, we're going to say now instead of passing that traffic to the actual container running in the pod in the remote cluster, we'll
Uh-huh.
route it to my local machine. That
So
makes sense?
Ingress wants to talk to stuff on my cat, or
Yep,
that's the user, and
that's
so
right.
it goes to the Envoy proxy,
Yep, we
and
configure
then
it so that's like oh sorry, go for it.
the Envoy proxy sends it, instead of sending it to this application running, it sends it to the same application running in local development.
Perfectly said, because we did my bad, we forgot that's a prerequisite. You would typically be spinning up that local service like I love IntelliJ, right? VS Code, pick your poison. Like your local IDE, your IDE locally will be running the service, the microservice, Whitney. So good call out there.
So then I don't think I'm going to draw it because I think there's probably more to this just talking to that. I have questions, but we also have a
Go.
question in
Yep.
the Alexander, thank you for coming. What permissions in the Kubernetes cluster does Telepresence required to have? Because usually developers have limited users for accessing a remote cluster.
Yeah, great shout, Alexander. And like nearly everyone in the talks I do, particularly the ops folks, are flagging like this sounds really dangerous. How do I stop this happening? Right? Because I do not want telepresence running in any of my clusters. Right? So it relies on the like you can configure it via RBAC. So if you as a developer have got access via kubectl, like you're usually pretty good. I can't remember the permissions off the top of my head. If you pop along to our docs, Alexander, like the link Whitney very kindly put earlier on, you'll have that we do explicitly call out the permissions of what you need. We generally find in dev and staging environments, providing the organization is happy with folks like using kubectl, you're good to go. We definitely do have customers, users that have really locked down clusters, and then we work with them to configure, like, make sure that's stood up. But in general, like, and particularly in like the OSS community, we find that most folks have kubectl, like RBAC configured with kubectl access. They're good to go with telepresence.
Cool.
So what I say to the security folks, like, I'm like, hey, do you give kubectl access to your production clusters? And they go, of course we don't. I'm like, you're good, right? If you've got RBAC locked down properly on your production clusters, which they all do, like no one can, like, telepresence is not like magic security hacking type thing. It respects fully the kind of
The
permissions you've
rules
got,
that are
as
in
far as I
place.
understand it, I should say. Yeah. Yeah.
Cool. And then these users we're talking about are usually that's not an end user. We're talking about someone who's developing and testing.
Typically, when we get on, there's a sort of like, there's what's called personal intercepts, which uses headers which we can then like be sort of a bit more clever about what we route to our local machine and not. Then you can do this kind of testing in production, but perhaps put that aside for the moment. But I'm with you. Like, primarily, it would be me and you. If we're coding on the service, we'd be hitting the endpoint, right? But maybe we want to share it with our stakeholders, right? We want to share it with the QA team. We want to share it with I don't know, our product owner, our product manager, right? So like we can, like, long as folks can hit the ingress, and like when we've got telepresence running with the intercept, they can see what we're doing on our local machine. We make changes. Like, there's no need to do the build, push, deploy thing I mentioned earlier on. We make changes and it instantly shows up for the user hitting the ingress.
So the Telepresence Connect opens the tunnel.
Yes.
And then the Telepresence Intercept has to do with somehow with this proxy and taking the request away from what's actually running in the cluster and routing it to your laptop instead.
Perfectly said. Yeah, and like the way I phrase it is like it intercepts the request and reroutes it to my local machine.
And I guess I'm trying to figure out how to capture that here. Is it still going through the traffic manager?
Oh, you're stretching my knowledge. No, Whitney. No, I don't think so.
Okay.
Because again, the architecture has altered from V1 to V2. I don't think it is, but I'm trying to think how it does egress from the cluster. Oh, I might have to get back to you on that one. That's a great question. That's a great question. I've not been asked that one.
And in our example too, we have it coming in through the ingress, but it doesn't have to come in through the ingress. It can come in through this Telepresence Connect
we've got
tunnel.
that two-way thing. Like we can sort of poke it. Like I guess, like, that's a really good question. I guess the common use case I see is like we would test our service via the ingress and then make changes on the service being intercepted. That makes sense.
Yes.
So like, the reason we use the Telepresence Connect is more to poke around with our dependencies in the cluster.
So test changes here.
Yeah, perfect.
And so basically, I want to draw a line from this cat app through to the Envoy proxy, but I'm unclear. But whether I go through the traffic manager, around the traffic manager.
Yeah, let's go through. I mean, I think and I'm apologies, folks. I'm pretty sure my lack of understanding, because we've changed it a couple of times, the mechanism it uses. I think it would, like, the best way to draw it would be to go through that tunnel. I don't know if I think it does actually hit the traffic manager. Oh, that's embarrassing. I should know that.
No, it's fine. It's fine.
Yeah, I'm just thinking, because we use something called a ton device now. We did my colleague Jose did a fantastic blog post, or it's on the news stack, and he talks about ton devices, so I can share that link with folks later on. And I'm trying to think how it actually like routes it. I think it does go through the tunnel created, but I think if you draw that conceptually, Whitney, it'll be all good.
So we want to. Where is it? It starts from the laptop, and we want to affect our app here. And then from there, it goes to the telepresence daemon, maybe through the traffic manager, and then to Envoy proxy. And then we can access it as though it is this app running, but it's actually this one.
Yeah, it's almost the other way around, really, if that makes sense.
Yeah,
so like,
that's what I was.
yeah,
That's what I was. Yeah, I agree with you very much. But
it's
what I
like,
don't want is this. Okay. So let's think about this. So the
I think the original area there was good, Winnie, right? Because like we are
okay,
testing, so we hit the ingress, right? And the ingress
yeah,
goes through
this
to
actually
the
goes.
Envoy proxy, right?
Yeah.
And then the Envoy proxy routes that to our local machine.
So it's a two-way thing.
It's
Envoy
exactly
proxy
like,
to
yeah,
local
it's a two-way
development.
thing. Exactly, yeah.
I think I'm making it a little more confusing by pointing it back to the laptop. Let's just
Honestly, we
point
have
it
a
to here.
hard time drawing architecture diagrams, so you're not alone. And you're doing it on the fly.
Thank
We
you
have the
for
advantage
being.
of like statically drawing it, right? So no, like, yeah, this is great.
Yeah. Okay. So the app and the Envoy proxy, it's a two-way communication, talking to each other. And
Yeah,
then because of the Telepresence Connect and the Telepresence Intercept, any other thing that the Envoy proxy is also using can be used by this local app. So I would
yeah,
love to
yeah,
capture that. So we have a Postgres database. Was that right?
yeah.
With
That
all of
works.
the stuff and all of the cats.
Yeah,
Um,
yes. 2
and
tables,
then
stuff and cats.
and would that be better represented as a like a pod running in the cluster or as like a external service or
You can do either. I think for simplicity, let's keep it as a pod, Whitney, because then like
okay.
we know it's network addressable, right? Because like sometimes there's some interesting stuff if you're running it as a service.
Okay, so we have a database. I'll put it, and then does it have its own online proxy? No.
No. So like when you say you were like on your local machine reaching into the database, you're going through
Uh-huh.
the traffic manager definitely there, right? So the traffic manager is the pod in this case, instigating the communication with the database. So the Envoy
Okay.
proxy is only really like in our sidecar example here, it's only really responsible for intercepting the traffic destined to its application.
So this app, if this whole thing didn't exist, this app would call out to the database just like
Perfect.
this.
Yep. Yep.
And with all this existing, this app also can just call to the database.
Exactly. Exactly. Yep.
Okay. Cool. So then it's as though it has database access, and this could be times
Perfect.
50, like every other, like
That's it.
any
All
other
your
thing
like
it
our other
needs.
like stuff on dogs like that could be running in there. Well, we can access that locally now, right? As if we were in the cluster too. Yeah. Perfect.
Okay. Cool.
That is telepresence in a nutshell, right? The two most powerful things are the connect and the intercept.
And the intercept like spins up the proxy.
It does, yeah. The intercept spins up the sidecar because you target the Kubernetes service, right? Effectively, or the deployment. You say telepresence intercept name of Kubernetes service or deployment.
And the service or the the deployment, like
Yes,
literally the
like
Kubernetes object of the deployment.
exactly. Yeah, so we
Okay.
call it a workload in the docs because it can be what can it be? It can be a deployment, a replica set, stateful set. I think there's a bunch of things we like. The docs are your friend there. Folks want to look at these. Yeah.
Okay. Okay. So the Telepresence Connect, put your laptop in the. Okay, here's a question, and I think I know the answer, but let's be clear. Can
Yep.
you run Telepresence Intercept without first running Telepresence Connect?
No.
Is there a big reason to separate out the two commands? Like, are there use cases for only Connect and not Intercept?
Yes, there are. So the telepresence connect is often just like a first stage. It's more like if you and I are chatting on the phone, I call you on the phone, right? That's our first like connect, and then the fact
Uh-huh.
like I don't know what actually that analogy is maybe not going to go. I'm not sure what the intercept would be, but like maybe someone eavesdropping on us, right? That's like almost a
Uh-huh.
second thing. But like you always need to connect to be able to intercept because like we need that
Uh-huh.
connection established, right?
Uh-huh.
But to your point, the use case, like definitely, like I've used Telepresence Connect just on its own when I want to poke around on a service running in a remote cluster or a database.
Okay.
A very common use case,
Where
right? I
you don't
want to
want to
run like
actually.
MySQL client locally, but I want to
Mm-hmm.
poke around on a remote database.
Mm-hmm. Cool. And then is it heavy on compute at all? Like,
It's
how's it?
definitely
Yeah.
not. When that was like
Mm-hmm.
a use case sort of to come around. Because you imagine, say we had to spin up all of our stuff on animal services, right? Maybe like 50 services. Like imagine we'd need a really powerful local machine, right, to spin all those
Yeah.
things up.
Oh yeah. Uh-huh.
Whether it's running in Minikube or whether it's running like on our like laptops as processes. Whereas like the Telepresence daemon is super lightweight, and all we
Okay.
need to run is our one stuff on cat service, and we
Uh-huh.
can interact with all the other services as if they were running locally, right? So it's you can
Uh-huh.
almost like sort of cliche is to run like a real lightweight like kind of dumb terminal or a lightweight terminal, and then
Mm-hmm.
interact with like remote services.
Cool. Developer guys here and said hello. Hi, developer guy.
Hello.
Thanks for
Ah,
coming
I
by.
recognize. Yeah, we chat regularly on Twitter and LinkedIn. Hey, good to see you.
Thanks for coming. Cool. I feel good about this. How do you feel about it?
I feel good, Winnie. There is one more layer to put on top. That
Uh-oh.
Yeah, it's where the magic happens. But shall I
Uh,
talk you
oh,
through
I
it?
thought
And
this was magic already.
it is.
I
And honestly, like Telepresence. So I've been super lucky in my career to work with many amazing open source projects. But Telepresence is the only one I remember this distinctly at the KubeCons where I demo it and people would clap halfway through the talk because it was genuine magic, right? They were just like, I did. Where was it? It was San Diego. I think it was. We did Telepresence. We did KubeCon in San Diego, right? I think one year, and I did the demo. And the connect, like people were like, ooh. And then when I did the intercept, people were like, and I was like, wow, like, the tech's cool when people are clapping halfway through your talk, right? So that it genuinely like it's not magic, and like amazing folks on my team, like Nick and Thomas, who do like, well, they're the engineers that like there's many other engineers in Best Labs who do amazing work, but Nick and Thomas I'm frequently chatting to. Like I say to them, like, it's clearly very cleverly engineered tech, but to the person outside, it looks like magic, right? And
Yeah.
they do amazing work, like putting all this. I'm just talking about it. They're the ones building it, and the community, of course, are doing amazing work. But it kind of is magic.
I have questions.
Go for it.
I have more questions. When the user wants to experience comes in here, what they're getting is what's on the developer's laptop, yeah?
Exactly. And that's the beauty, right? Because
Okay.
you and I can change what's on that laptop super
Uh-huh.
quick, right? We no need to build a container. We literally just change some code, restart our process and our IDE. And if you
Uh-huh.
hit that endpoint, you will see the change instantly.
So this is my question then. Why is this even here? And when does it get updated with the most recent changes?
Oh, great question, Wendy. So yeah, maybe that's my sort of expert blind spot, I think, on this one. So we talked about like you asked the great question up front. What's the pain point? And it was like if we wanted to change something in our stuff on Cat's app, the sort of
Uh-huh.
without telepresence, we'd make some
Uh-huh.
changes locally, right?
Uh-huh.
We'd compile the app, we put it in a container, and we
Uh-huh.
push it up to our remote cluster, and then you and I would test, right? But imagine
Mm-hmm.
that's like super long process. We want to stay in the
Yeah.
flow in the zone, right? So
Yeah.
now like we do a request, it gets routed to our local machine, right? Then we see the
Uh-huh.
results. Then you and I could literally make a change in the code and like probably,
Uh-huh.
if we're in debug mode, it'd be automatic, hot reload or whatever, or we can just recompile the app locally. Then if we
Okay.
make a request again, we get routed straight through to our local machine. We see the change instantly. No need to build a container. No need to push the container. You and I are like
Yes.
pairing literally live, and then we
Uh-huh.
go, oh, we'll change all this like different breed of cats, right? We want to test it, something
Uh-huh.
like that, and then you hit the ingress, and you will see
Uh-huh.
that change like in sort of near real time, right?
I see the change because I see what's happening here.
Perfect,
Yes.
perfect.
I follow that, but then what I don't understand is what is this application, the real one that's running in the cluster? Is it needed? Does it
Oh, I see your
change?
point. Yeah,
If you're
because in the
skipping it completely,
yeah.
why? Yeah.
Oh, great question. So in the old days, we would like sort of replace the whole thing like with this proxy, right? And then we just route. But now, so like maybe this will help you, Winnie, because it's a really good question. Is when we disconnect, we do like telepresence
Mm-hmm.
quit is the command, right? Um,
Mm-hmm.
the effectively like depending on how you look at it, the connection is broken, and anyone hitting the ingress will now go to the old app.
Okay.
Does that make sense? So, and if we wanted to update the app in the remote cluster with the
Uh-huh.
changes we'd made, so we tested our
Uh-huh.
changes. We went super fast. We made a bunch of changes. You and I
Uh-huh.
pairing, like all fixing stuff, right? Very fast feedback loops. When
Uh-huh.
we're happy, we would then push it
Then
into
do the
CI or
then do the long process of
you got it,
updating
you got
this
it.
app in CI/CD.
That's
Okay.
it, exactly. So yeah, that's a really good call out because some people say to me like, is it a replacement for CI/CD tools? No,
Uh-huh.
definitely not. It's a development tool, a development a development and debugging tool.
Am I drawing more in this cluster?
Well, I wanted to pitch you the personal intercepts thing, but like I don't know,
Okay.
like do you want to?
Yeah, I'm up for anything. I like to say yes.
Yeah. Maybe I can run you through because this is sort of the Telepresence open source model, and then there is some like this community edition we sort of build layer on top where you we do give you that use case when you want to share clusters, but that is in the the commercial version of Telepresence. It's a separate build, but it gives you a lot of flexibility where instead of doing like the global intercepts, you can use headers to route personally. So you can imagine on your diagram when you'd almost have like many different laptops below,
Uh-huh.
and we'd
Yeah.
have different headers for each one. So you'd have your header, I'd have my header. Then we could be intercepting the same service, but when we test on our our laptop, our user laptop, we'd inject a header, Whitney's header, and then that Envoy proxy would selectively route to your machine. Does that make sense?
So if I want to develop, if there are 3 of these, let's
Yeah.
say,
Perfect.
and
Yep.
so all 3 of us are developing stuff on my cats.
Yep.
And it knows which is coming to mine and routes accordingly, makes the changes just that I made, only reflects those changes and ignores everyone else's changes, or do I see other people's changes?
No, if we're all intercepting the same service, you would only
Uh-huh.
see your changes.
Okay. And
Yep.
then when a user comes in, where do they go?
If they use no header, they would see
Mm-hmm.
what's in the cluster.
Okay.
So that is
Okay.
I like your questioning because that is and again not everyone does. We do see a few folks doing stuff in production. This is the only
Uh-huh.
case when you would do it in production, right? Because a user normally would just see the results of the normal app, whereas you and I
Yeah.
would be putting headers in and we're seeing different stuff. But if you're doing a
Okay.
global intercept like we talked about before,
Mm-hmm.
everything gets routed to your local machine.
Okay. And what you're describing with headers is part of the proprietary stuff, or is this
Yeah,
part of the
exactly. It's
open
layered on
source
top. So it's like
project?
an open core
Okay.
model, just to be super clear, folks. Like the telepresence, like CNCF, like separate binary, does the
Uh-huh.
global, and then we'd layer on the personal intercepts in like the proprietary thing. Yeah, yeah.
Okay, cool. Therefore, I'm not going to capture it on the board, but I do like talking about it.
Yeah, yeah.
Sweet. This is so much fun. Okay, so I still have a lot of board space. So I think,
Yeah.
yeah, do you have a lot more to teach me, or maybe we can put some words to how this translates to a different developer experience?
Yeah, so a
Or,
couple of things I'll just throw in the mix, Whitney, and then I
yeah.
think I like the idea of doing like some words. With like OSS telepresence, there is a couple
Mm-hmm.
of magic things. In addition, you can
Nice.
mount remote volumes. So it's very common in our pod. You might mount,
Mm-hmm.
I don't know, like a TLS certificate or some kind of config, right? You
Mm-hmm.
can, and it depends on like your target OS locally. So whether you're on like Mac or Windows, Linux, you can mount volumes. So that is kind of magic. Like on Mac, it's a little bit fiddly because you have to use what's called Fuse, and like it's not so well supported in the modern versions of Mac OS. But you can map remote volumes to your local machine, which is pretty awesome. And on the same tip, you could
Hold on. Mount remote volumes. I would like to talk more about that. I would like to figure out how that fits in the diagram.
yeah, that's gonna be a tricky one there. Yeah.
Yeah. Remote. Okay, to your local machine. So a remote volume would be like if there's storage that's outside of the cluster.
As the storage in the cluster, so you've defined like a
Okay.
persistent volume. So like I'm trying to think, I mustn't paint myself into a corner here, because we don't really see it used much with the database use case. It is more of a case of folks loading some kind of config or some kind of secret in a
Okay.
file, and like to develop properly, you need access to that secret, right? Or that
Okay.
that thing, and like they're like, how am I going to do that? And it's like there's a bunch of ways you can do it. You can try and replicate it locally and stuff, but you can, as an option, mount that remote volume on your local machine.
And then how, when you incorporate the changes and you disconnect and you want it to reflect here, how does it, if it doesn't go through the
Yeah,
CI/CD
so
process?
imagine like say we were developing on something like our stuff on cats, and we needed a I hate to use the word secret because like Kubernetes actually has secrets, right? But like
Yeah,
say we needed a file, right? Like for our
Uh-huh.
application, like for you and I to develop, we needed
Uh-huh.
access to this file, right?
Uh-huh.
Now what we could do is we can just do the standard telepresence intercept, and we could like
Uh-huh.
copy that remote file to our
Uh-huh.
local machine, right? And it would all
Uh-huh.
work up fine. But
Uh-huh.
say like we didn't like that file changes a lot or whatever, and we
Uh-huh.
just want to sort of auto magically copy that file to our local machine. We do the telepresence volume mount, and we tell our application like you can access this remote file on the local machine.
So is this file, this remote file, is it like in etcd? Is it like literally in the file system of
In
this
the file system. Yep.
machine?
Yep.
Okay.
Yep.
Okay. So it's not a Kubernetes config map or secret. It's a file system
Yeah, because you can map like
file.
sort of config as like a file in a volume, right? So because it was stretching the limits of some my understanding. So because if it's like it's definitely a volume, like we mount because we have had some
The
challenges with config
Kubernetes
maps.
sense, like a
Yeah,
volume mount on a pod.
yeah,
That,
exactly. The volume mount of a
okay.
pod, we can effectively like
I guess.
mirror that
Uh-huh.
locally.
Okay. Yeah, I always see the volume mounts being, in my limited experience, usually being related to a config map or a secret. I always thought those were
Agreed.
ultimately in etcd though, and not on the
Yeah, and
actual
that's why I was sort of like
machine.
trying to think. This is like we see it actually it's pretty common, but it's not like an everyday use case. But it is one of those things where people have certain workflows. They go, I always need this file to be able to
Uh-huh.
develop, and we're like, don't worry, we've got you covered. Do you know what I mean? Like so, like
Okay.
there is an option that you can mirror effectively the remote volume to to your local machine. Like for
Uh-huh.
like things
And
like config maps, secrets, other options.
two-way, what do the mirror, it's a
Ooh.
two-way mirror?
Oh, that's a great question. No, I don't know really. Like, I've only ever used it to mirror a remote thing locally, and it's basically like a static file, right? I never change it.
Okay.
I don't
Okay.
think it's two-way. I
Okay.
don't know. I'll have to get back to folks on that. That's a good question. Yeah.
Okay. Okay, I really like, I love saying I don't know, actually, and I
Yeah.
appreciate you saying I don't know.
Yeah, these are good questions. Yeah, I guess like with telepresence, it's like sort of the 80% use cases I'm so used to in all my demos and things, right? And then when we start
Uh-huh.
going off on the standard use cases, I'm like, oh, this is a good question. I'm not sure.
Cool. Excellent. So that's one magic, is that you can mount remote volumes to your local machine.
Yeah, and the other one is you can copy environment variables. So another way that folks, particularly if they're familiar with something called like 12-factor apps, the way
Mm-hmm.
to specify, like you mentioned, like config maps and secrets, Winnie, but the way
Mm-hmm.
that a lot of the folks who are familiar with 12-factor apps, like came from the world of Heroku, was to
Mm-hmm.
put your config as an environment variable. So you might
Mm-hmm.
have, for example, your database location as an environment
Mm-hmm.
variable, like Postgres dot whatever, right? Um,
Mm-hmm.
we can transfer them to your local machine. And you can either add them to your local shell. So like if you spin up sort of a shell, like a terminal,
Mm-hmm.
you can access the environment variables as if they were local. There's
Mm-hmm.
another way where you can download a file and you can load that file of environment variables into your IDE. So for example, I'm a big IntelliJ user, JetBrains user, and there is a
Mm-hmm.
plugin called, I think it's called like env file plugin. And
Mm-hmm.
you can, when you do your telepresence intercept, you can say, generate me an env file, and it will generate like all the environment variables in that pod. And I can then load that M file. It generates it for me on like, my local machine, and I can
Mm-hmm.
load that M file via this extension plugin in IntelliJ into my current session in IntelliJ. So IntelliJ can then access the environment variables on my local machine that that are the same. They're not mirrored because like, I download the
Mm-hmm.
file, right? But like that
Yeah.
it's like I'm using the same environment variables, and that's pretty awesome for folks. Because a lot of the people that come from Ruby in particular, some of the Python folks as well, but Ruby I see a lot. They use this 12-factor app principle, and all their config and secrets are often put in environment variables.
Cool. And that's another thing. If they want to change it, is it changeable, or is it just a thing that doesn't really get changed?
Like if you wanted to update the data.
Yeah. Uh-huh.
No, I think because like basically from my understanding, it generates like a static snapshot. So if it did
Okay.
change, Whitney, like you'd have to do the intercept again and regenerate the file.
Okay. Cool.
Yeah, good question.
Yeah, thanks. So what is telepresence? Like, let's write down a definition of telepresence. I feel like
Oh yeah, this is good. So the way I say telepresence is a remote to local fast feedback development tool.
is a remote to local
Yeah.
fast feedback development tool.
Yeah, and probably should say for Kubernetes because like that is it is a
Yeah.
Kubernetes thing. And if folks have got a better suggestion, I'd love to hear it because we struggle constantly on like the GitHub on our website, right? There's a few sort of similar tools, but not like Telepresence is quite unique actually. And like, yeah, coming up with the exact right words really hard.
Um, my fast feedback is, I would consider saying, instead of fast feedback, real-time development tool,
Ooh, I like it, Winnie. I like it. Yeah.
because the idea of fast is subjective.
Yeah, everyone, yes.
and I don't trust marketers with words like fast.
It's interesting you say that though, right? Because I have people push back on real time because like
Uh-huh.
real time is like a lot of stuff isn't real time; it's near real time.
Oh,
You know what I mean? Because I worked
yeah.
on a bunch of stuff like with message queues, and the
Uh-huh.
vendor said it was real time, and we were like, "Is it
Uh-huh.
really real time?" And they were like, "No, it's not real time. It's near real time." So that's the only thing.
But
I think that's why we stayed
okay.
away from real time because like
But
real.
what about near real time?
That could work too, right? I've got so used to saying fast feedback, like it's almost
Fast feedback's
unquestionable.
nice.
But but your point's well made, Winnie. Yeah, yeah,
Oh yeah, and fast feedback is like a common term. Like it's so it does have a connotation of like a feedback loop, and but
that's it. We often talk about the inner development loop, right? So like we're
uh-huh.
trying to like optimize for fast feedback. Like if you're a developer, like and like if, the classic when I was doing test-driven development, you did red,
Uh-huh.
green refactor, right? You get that fast feedback. You put up a test, it goes red. You write some
Uh-huh.
code, it goes green, and then you refactor that test to like be concise and understandable. And that's where I was always, as a Java developer, I was always optimizing for fast feedback in that
Uh-huh.
little inner dev loop there, right? And now
Uh-huh.
the inner dev loop expands out to like Kubernetes services.
So making containers and yeah,
Yeah.
uh-huh.
Exactly.
Napalm's here. Hi, Napalm. So glad
Hello.
you came. Napalm is late to the conversation, but this is actually good. How does this compete with,
Ooh.
say, K8s and Minikube, etc.?
Yeah, that's a great question to open with, right? So
Yeah.
they're two different styles, really. You can totally spin up, particularly if you have a small application, you can totally spin up stuff on a local machine. And if you're actually like trying to make your local machine as production-like as possible, you would
hmm
run a Minikube or K3s or all these kind of good things, right? Because it's like running a cluster on your local machine.
hmm
Um, but there comes a point where you cannot physically deploy all the microservices because your
hmm
machine has got limited resources.
hmm
And then ways around this is you can maybe spin up a subset of services in Minikube, right? As long as you don't need the other services, it's kind of fine. You can test against them. But there typically comes a point where you want to interact with just more things, or it's easier, particularly when you've got a big application, because the
hmm
services are changing so much. If you run stuff locally, you need to reconfigure that environment every day. Because like
hmm
you push some stuff, Whitney, right? Lisa's pushing some
hmm
stuff. Like I push some stuff, and then every morning we need to log on and go, right, what's our local environment look like today? Whereas if you're using that shared thing, that shared cluster, hopefully someone else is
hmm
doing that automatically for you, right?
Uh-huh. So Napalm uh, says their desktop is a beast. Good for you, Napalm. um, but so being late, Napalm, what's happening is we're giving a near real time development experience to developers, so they can develop their Kubernetes apps locally, but they can access every single other service or application that's also running in the cluster, and so have all the development tools that they're used to, but also be able to access every database, every environment variable, everything that they could possibly need. And yeah, that's the.
Fantastic,
Is there
Whitney.
something that?
Fantastic.
Mm-hmm,
No, yeah,
cool.
love it.
And that's done really with proxying, by proxying requests.
Yep.
So there's a connecting command, so you could just interact with everything that's there. But if you actually want to like develop your application, there's a proxy. So anything that's meant to go to the application in your cluster, it gets rerouted to the application you're developing on your laptop instead.
Boom. Drop the
Napalm
mic.
approves.
Drop the mic.
They're still nice. That's cool. But let's so Telepresence is a remote to local fast feedback development tool for Kubernetes.
Yeah.
Yes. And then what it enables developers to do, maybe like so they can interact with, they can see how their changes will be reflected in the cluster without having to rebuild a container that encapsulates their changes.
Yep, love it.
Okay, now I have to write it. It's a wordy thing to write down.
As you were saying, I was like, this is great, but yeah, it's quite a lot of words there, right?
So devs can see the changes. What other tools are in this space? You know?
So it's quite interesting. I was chatting to my buddy Costas at CodeFresh the other day around this. And the Telepresence, his pitch was actually quite unique in the way it does this. There is, I think it was Cube Forward that did, Kelsey Hightower doing a demo that quite a while ago now. It's pretty awesome. So Cube Forward. And I think that's kind of like folks that are familiar with kubectl port forward. It was kind of like that, but more advanced. So it didn't do all the things we talked about today, Winnie, but it did set up. I think it set up based on, I think it was ports. Like you could have a file and define all the remote services you wanted to interact with. I think you had to specify up front what services you wanted to interact with, whereas Telepresence, you can connect into the cluster and just like access everything. But Cube Forward is very good for the sort of analogy for networking. There's K-Sync, which synchronizes your local file system with a remote file system. So the K-Sync effectively, like say you and I are making changes on our IDE locally, behind the scenes, K-Sync would synchronize those like either the code files or the compiled files with the remote pod. So we can like, we're not uploading the whole app and building a whole container, but we're like building, we're transferring files between our local machine and remote machine. So that's the two sort of principal tools that like, and there's a bunch of other ones like I mentioned in a minute as well, but they're two kind of like OSS tools that kind of do subsets of what Telepresence does.
Okay. Napalm says Gitpod.
Oh, yeah.
Gitpod is kind of like this.
I love the Gitpod folks. Got to shout out like a bunch of awesome folks at Gitpod. Gitpod is a remote IDE. So like you're running your whole development environment in the cloud there. Right. So it's kind of like, it's definitely a similar pain point, perhaps a different solution. And they both have strengths and weaknesses. I'm trying to think what would be the best. Like I do like, and I mustn't speak out of turn with Gitpod. So if you want to find out about Gitpod, Pauline is awesome on Twitter. I can hook you up, Whitney, if you want to find out. Pauline's like an amazing dev advocate at Gitpod, and she's got many other good folks there as well.
Is Gitpod CNCF? I don't think so.
No, like, I think some of the tech is open source, but yeah, maybe not CNCF. Yeah.
I've become a CNCF snob only because there has to be like some line you draw about where you.
Yeah, I think like open source, but yeah, not maybe CNCF. I'll double check with them, but yeah.
Cool. And also the other show that I'm doing now with Victor is called You Choose, where we're navigating the whole CNCF landscape. Again, drawing that line just to limit the choices, because otherwise we'll do it until we die.
Yes, fair enough.
Or like never really move the story along because we're just stuck on one like possible problem to solve forever.
Yeah, I like it. Makes sense.
Napalm says, yeah, I like this better than developing on a VM pod in the cluster. Is that what you usually do? Yeah.
That's well sort of phrased, Napalm. Like and that's where I was trying to go with that, like with Gitpod. And there is other solutions like that. You are effectively like spinning up like your whole IDE, your whole development environment in the cluster, Whereas like the way you drew it there, Whitney, we're keeping our local machine like in our local development environment local, right? And you and I, and I'm sure Napalm and other folks, we have our laptop configured exactly as we like. Now with things like Gitpod, and there is DevBox with Microsoft, and there is an open standard emerging there. I don't think it is CNCF yet. It may well become one. There is ways you can configure and save like the remote development environment as well. So folks are interested, I think it's a Microsoft spec, DevBox. So like there is things emerging in this space, but yeah, with this approach, we can have our local machine configured as we like, and then we just reach into the cluster.
Love it. So Telepresence is remote to local fast feedback. Devs can see the changes that they make and how the latest version behaves in their Kubernetes cluster without having to build, push, or run containers.
Yeah, and I would say at that point, Whitney, devs and stakeholders, because QA folks love this, right? Because they can get it like fast feedback, and PMs love it as well, right? Because they can say, hey, what does that like new component look like? And it's like, well, let me just Telepresence, intercept and show you.
And stakeholders are going to access it more this way.
That's right. Exactly. Yep.
Cool.
Yep.
And then you talked about pair programming. How does that work?
So great question. So the example I use, so you can either be like pair programming on like we could be in the same room on that local machine, right? Or what I've seen, particularly during the pandemic, folks were effectively sort of pairing, and the person driving, the person typing, would be the one on this machine running Telepresence Intercept, and their navigator would just be poking stuff in the ingress and seeing what happens. It goes, like what's going on?
Okay.
You might screen share as well, and to Napalm's point, like things like Gitpod and other solutions, you can actually like pair program in an IDE together. Like some folks have compared that, or used that with Telepresence too. So there's a bunch of ways you can pair program with this approach.
Cool. Are there more benefits of Telepresence? So we can see the changes, and so can stakeholders without having to deal with CI/CD stuff.
That's the big thing. It's keeping yourself in that fast feedback loop, that flow zone.
Okay.
Right? Yeah, no need to break out and start building containers until you're happy. Like, still love the Docker build at the end, but that is when you're kind of happy with that fast feedback loop.
Stay in the flow zone.
Let's go straight on the website, that one. Let's make that up.
I love the flow zone.
It is so important, right? As a developer, like as soon as you have to break out and do a bunch of other stuff that's kind of like toil. I think the Google folks are like, toil, right? It is like, oh no, I just want to code stuff. I just want to build cool stuff, right?
Yeah.
Stay in the flow zone.
And then you have 1 minute, and then you I'll just check Slack real quick, and then 15 minutes go by. Yeah,
100%. I'm terrible on Twitter. Twitter's my thing, right? I'm like, oh, look at Twitter. Oh, interesting. Gone.
It's like the anti-flow zone. It's what's the opposite of a flow zone?
Distraction zone.
Stagnant is the opposite of flow. What's opposite of zone? Anyway, it's a stagnant sinkhole.
Yeah, like
that. Slack stagnant sinkhole. We're just gonna a flow dam says. So what is there anything else that you feel like I should know about Telepresence?
What else? I have a few notes actually. Yeah, I'll quickly look at them.
Yeah.
I think your questions have been great because you've covered all the things that pop up.
Or is there something you feel like we've talked about that I didn't write down that should get captured on the board?
I think most of it's good actually. I'm trying to think because there's definitely we sort of touched on best practices, right, for development or on Kubernetes. And I think there is different ways you can use Telepresence if you've got your own remote cluster. You can use Telepresence if you've got a shared cluster. I don't know if we want to touch on best practices. I kind of see as folks sort of start small, they're just running everything on Minikube locally. Then they might go to an individual. So there is a kind of journey is where I'm going with this, right? Like a journey of adoption. then you might start like, I'll just spin up a remote cluster because there's only 5 of us in the team, right? Remote cluster each, remote, and then you might use Telepresence to get that fast feedback loop still, because it's you still don't need to do the build and push every time. But then there comes a point where it just gets more expensive, like cloud costs, or you're constantly tripping, like well, not constantly tripping over each other, but like more expensive or more difficult to configure to keep up to date the remote cluster. That's when you might move then to the shared model that we talked about, where we have, like, say, just, you know, I don't know, like 3 staging clusters, and there's 10 of us now, like, interacting with these things. So there is a journey for folks to go through. So like, I never like to say like Telepresence is like, you know, we love it if you like, if you start with it day one. You don't have to, and it's, you can use it, and all these similar tools, right? You can use them as part of the solution in your journey.
So Telepresence is helpful for every stage. And when you say journey, you mean like journey of Kubernetes adoption, correct?
Yeah, Kubernetes adoption or building your application, because we've definitely had folks, because, you know, I've been with the company for like 5 or so years now, where like we've literally seen companies start with like just 2 or 3 services. They've done amazingly well, and now they're up to like 100 services and like 10x the number of developers, right? And Telepresence is still useful, and if not more useful actually, as you scale out large.
Maypalm says they have a K8s Raspberry Pi cluster. Can they do development on an x64 machine that pushes to the cluster with ARM64 architecture?
That's an interesting question. Well, I don't know if I'm that. That is a good question. So you have to emulate on your local machine the target architecture, right? Which I think, like with Docker and stuff, you can, like with VMs and Docker, you can do. Maybe getting outside of my comfort zone, if I'm being honest, Napalm, it's an interesting thing. And we do actually see, like, we have bumped into this use case with folks doing like edge technology, right? They're actually like, they've got an x86 machine or whatever, but they're building for ultimate deployment somewhere else. So I know Docker Build Kit is very cool in terms of target architectures now. But as long as you can emulate locally what you need, Napalm, like no reason like you can't use Telepresence to route that traffic to your local machine, would be my sort of back of the napkin answer.
Oh, I like this. So Napalm says, I love this idea.
Yeah, it's a good question. And I can see that becoming more popular, right? As in, like, we sort of joked about the nano services earlier on, right? But we see a lot of people now writing edge technology stuff. So like deploying it like either sort of like closer to users or telcos, like these kind of folks we work with. And they do have different architectures. So like all the big clouds, right? ARM is becoming like super popular, right? In terms of like the Graviton processors and all these things. So yeah, I'm thinking we'll probably see more and more of that. Interesting.
Nice. Love it. All right. Are we feeling a recap?
I think that sounds great, Winnie. Yeah, there's a lot. You've done a fantastic job because there is so much to cover, and I legit struggle explaining, but the questions have been fantastic. Love it.
Great. So the problem before Telepresence, which is actually a pretty real problem that a lot of people face even now, is that it's hard to get fast feedback when developing applications. It's hard to run Kubernetes locally, or if you're trying to run Kubernetes remotely, it's hard to, you have to build a container and push a container and redeploy a container, go through the whole CI/CD process to be able to see your changes. And that takes you out of the flow zone.
Oh, yes. Perfect.
You got to stay in the flow zone. But it's a real thing. I'm laughing, but that's a very real thing. I need to stay in the flow zone personally. So Telepresence is a remote to local tool for fast feedback or near real-time development tool for Kubernetes. So you can do all of your Kubernetes development in a remote cluster, but you're getting real-time feedback over how your app is changing and how it interacts with every other app that's running in the cluster.
Perfect. Yep.
So how it works. If you're a local developer and you want to start using Telepresence, first you would run a Telepresence Connect. Well, first you would have to download the Telepresence daemon, right?
Yep.
And and then you run the Telepresence Connect command, and that it opens up a tunnel. You said
I like it. Yep.
to the traffic manager that's running in the cluster, and then you can access anything in the cluster through your development laptop without having to go through the ingress like a regular user.
Perfect.
So you can query apps that are running, but you can't actually manipulate anything at this stage. But for stakeholders, like you said, testing or QA or PMs, they can be poking around through this. They can also be poking around just through accessing it through the ingress too. So that's step one. And then step two is to use the telepresence intercept command. So what that will do is create an envoy proxy and emissary proxy. I don't know the difference.
Envoy proxy. So emissary ingresses are like, it's actually an ingress, a gateway, a north-south
Oh,
gateway.
got it.
So
Okay, cool.
it's based on envoy proxy. So envoy proxy is the engine, and in the container, in the sidecar, it's pure envoy proxy.
Okay,
well,
got it.
actually not pure, a few things added in as well in the mix.
Okay.
Yeah.
So the envoy proxy is, you use the word sidecar. Sidecar just means a second container running in the same pod as the application.
Perfect.
And so that envoy proxy gets spun up with the telepresence intercept command. And now with that, your any traffic that's meant to go to the application that's running into the cluster gets intercepted, gets hijacked, and it doesn't actually hit this application. Instead, it goes to the version of the application that's running in your local development laptop. So we have our Stuff on My Cats application, which after this, I'm totally going to go to Stuff on My Cats and see if it still exists.
I'm going to check it out. I've never heard of it. Fantastic.
This thing is like 15 years ago, at least, that my son and I were messing with this. And so Stuff on My Cats. So locally, I can develop Stuff on My Cats. I can make changes to Stuff on My Cats. And all the traffic is going to go to, I'm going to see what it looks like when all the traffic goes here. But I can also interact with every other service that's running in the cluster as though it's more like my laptop's in the cluster than the services are outside of the cluster. But really, either way, you look at it, right?
Yep.
And so they're running local to me. So we use an example of like a database pod that's also running in the cluster. So I can just totally access everything in the database as though I'm in the same cluster as the database.
Yep. Perfect.
So yeah, so I can do, so I can use all my local tools. I don't have to build any containers. It all really happens really fast. I never leave the flow zone.
Love it.
Yeah. And then I was curious about this application that is running. If it's getting completely bypassed, like, why is it even there? And so it's there. So when this shuts down, when you're done developing and you telepresence quits, I believe you said.
That's good.
Yeah.
Yep.
And you're gone, then the traffic's gonna go back to going to the regular app.
Exactly.
And if I want to update the real app that's really running in the cluster, I would do that through the regular CI/CD process.
Perfect. Yep.
Yay. And so other magic, you can mount remote volumes to your local machine. So we're talking about config maps or secrets. You can also copy environment variables and transfer those to your local machine. And then to consume those, you can either load those environments into your local shell, or you can generate an in file and load it into your IDE that way.
Perfect.
And I think that's all. Telepresence is helpful for building apps during every stage of Kubernetes adoption. So even if you just have a couple of them, you can still take advantage of that fast feedback. If you have a bajillion of them, it's a good way to see how they interact with each other. We talked about how you want to be deliberate about who's using telepresence when in your cluster, because they're how you're affecting changes on each other's applications and stuff.
The state was the key thing, really. Yeah, so it's the same age-old thing I've seen.
The state of this database from my local development environment.
That's it. And say I was developing as well, and I relied on some of that state, and you changed it. I would be like, huh? Classic, like I'm sure many folks watching have seen, like integration tests commonly do this. They change state data, but then if you're not synchronized or you haven't collaborated effectively, can totally throw you in a loop. So that's the big thing. Telepresence is pretty magic, but it cannot stop people mutating shared state.
It's powerful magic. And it should be used wisely.
Responsibly, exactly. Yes, 100%.
Napalm says, so gonna use this, I feel. Thank you so much. I learned something cool I didn't know about. That is the best feeling. We're just saying that at top. That's what keeps us here. That's why we love this job.
100%.
This has been absolutely wonderful. Thank you so much for being here. Do you have anything else you'd like to say before we dance it out?
No, I'm ready to dance, Whitney. I was going to say thank you so much. You've captured it. Like doing this in real time. I've got, I've watched your videos before, but seeing it in real time is super impressive. These are complex topics, but you've captured it so succinctly, and the questions have been fantastic. So thank you very much.
Oh, I appreciate that so much. Wow, I'm literally blushing. I don't know if you can. I'll just look away. All right, let's get this music going. Goodbye, everyone. Thank you so much for coming. Oops, that's not the right song. Lo-fi song. We would have been like, okay, anyway. Bye. Let's see your moves, Daniel. Come on. Yeah.
On the chair.
Yeah. All right.